Good evening and namaste, David and Anurag.
Good evening and namaste.
How are you?
Fine. Sir, I'm fine.
Good. We have already completed our two chapters earlier. First was rational number, second was powers. And now we are moving towards squares and square roots. Ready?
Yes, sir. Yes, sir.
Let us first understand what is a square root, square numbers. Square numbers. Before this discussion, you might have studied about natural numbers, integers, rational numbers, whole numbers, right?
Yes, sir.
Out of natural numbers, let us collect natural numbers first. One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 and so on. I needed this much number to demonstrate what I need. You know, these numbers are representing some geometric figures as well. Let us see how. 1 means in how many ways you can represent 1 geometrically. 1 can be the area of a rectangle. See how? Area of a rectangle, or you can say a square. If you draw a square of length 1 unit or 1 centimeter, breadth also 1 centimeter, what will be the area?
1 centimeter square.
L into B, that is 1 into 1. 1 into 1 square unit. I am not writing centimeter or meter, it may be any unit. So finally we get here 1 square unit. Now let us consider 2. In how many ways 2 can be represented geometrically? It can be a rectangle with length 2 units, breadth 1 unit, or the another one with length 1 unit and breadth 2 units. So 2 can be represented in 2 ways. The area of the first one is L into B, that is 2 into 1. So 2 into 1, that is 2 square units. The second one, L into B, that is 1 into 2, right? Area of these two rectangles are 2 into 1 or 1 into 2. So 2 can be represented in 2 ways. Similarly, 3 can be represented in 2 ways. 3 into 1, 1 into 3. Length 3 units, breadth 1 unit. In the second one, length is 1 unit, breadth is 3 units. Getting the idea? Getting the idea?
Yes.
In how many ways 4 can be represented? In how many ways 4 can be represented? Think and answer.
That's pretty good.
Sure? Are you sure?
Yes, sir.
4 can be represented as 4 into 1, 2 into 2, 1 into 4. Let's talk about 5. 5 can be represented as 5 into 1, 1 into 5. Do you think any more?
No.
No? Let's now talk about 6. 6 can be represented as 1 into 6, 2 into 3, 3 into 2, 6 into 1. 4 ways. Length 1, breadth 6, length 2, breadth 3, length 3, breadth 2, length 6, breadth 1, L into B. So we can represent these numbers as rectangles of some dimension. Similarly, we can move ahead. But now let us think of those numbers which are square numbers. A square number means where rectangle can look like a square. Do you think this rectangle looks like a square? The first one? Yes, this is a square. Do you think out of these two, any one of them looking like a square?
No.
That means 2 is not a square number. We cannot represent 2 with the same length breadth, but 1 can be represented as same length and breadth in a rectangle. So that's a square. 1 is a square number. 1 is a square number. So think of those numbers where you can draw a square with the same length breadth. I mean a rectangle with the same length and breadth. That becomes a square, and that's the reason we call that number square number. 1 is a square number. Do you think 3 is a square number?
I'll come in 1 minute, sir. 1 second.
Don't miss it. Go and come fast. I'll continue. Do you think 4 is a square number?
Yes, sir.
Yes. In this case, when you take a rectangle with the length 2 units, breadth 2 units, length and breadth will become same, and then that rectangle will be called a square. So 4 is a square number. Now think of 5. Do you think 5 is a square number?
No, sir.
What about 6? Do you think 6 is a square number?
No, sir.
Okay. So go on, continue and try to find the next square number after 4.
Sir, 9.
9. 9 can be written in many ways, like 9 into 1, length 9 units, breadth 1 unit, then 3 3s are 9, length 3 units, breadth 3 units, and then 1 into 9, right? 3 ways, out of which one is the choice, one of them is a choice to make a square. So yes, 9 is again a square number. Did you understand why do we call them square numbers?
Yes, sir.
The rest of the numbers are rectangle numbers. Rest of the numbers like 5, 6, these numbers are rectangular numbers. But 4, 1, 4, 9, etc. are square numbers. And of course, if you ask me, sir, 9 is a square number, can we say 9 is a rectangular number as well? Exactly, we can. 9 is a rectangular number as well, because when you make a rectangle with length 9 units, breadth 1 unit, 9 is a rectangular number also. And as you know, all the squares are rectangles, yes or no?
Yes, sir.
Every square is also a rectangle. That means you can say all the numbers are rectangular numbers, but some of them are square numbers also. 4 is a square number, 9 is a square number. Now David, can you find out the next square number after 9?
Okay, sir.
Be quick, I'll not wait for long. You take much time. A few students are watching the class on social media as well, on YouTube, Facebook.
12, sir.
Which number?
12.
12 is equal to what?
2 into 6, sir.
And both of them are same, right? 2 and 6 are same. That will make a square. You are saying that 12 is equal to 2 into 6. So that will not be a rectangle, that will be a square, right? Length I take 6 units and breadth I take 2 units. So you think it's a square, correct? That means you don't understand what is a square and what is a rectangle. You don't practice hard. You don't retain what you learn. Very poor. 12 is not a square number. Anurag, can you say what is the next square number after 9?
16.
That's correct. How can we write 16?
Sir, 4 into 4.
That's right. 4 into 4. 16 can be written in various ways, out of which one is this. Let's write each one of them. 16 into 1, or let's start with 1 into 16, 2 into 8, 4 into 4, 8 into 2, 16 into 1. So these are the ways you can write 16. So this one is a rectangular presentation, this one is a rectangular presentation, because length and breadth are different, they are not same. But in this case here, length and breadth are same. This is rectangular, this is rectangular. Okay, so there are total 5 presentations, out of which one is a square presentation because length and breadth are same. So yes, 16 is a square number as well. Can we say 16 as a rectangular number?
Yes, sir.
Exactly. And 16 is a square number as well, correct?
Yes, sir.
Very good. Now I hope you understood the idea behind a rectangular number and a square number. Is that okay?
Yes, sir. I understood.
So every natural number is a rectangular number, correct?
Sir, 36 also, sir.
Okay. Let's write the conclusion now. Conclusion. All the natural numbers are rectangular numbers. Rectangular numbers. Number 2, some natural numbers are square numbers as well. Is this meaningful to you?
Yes, sir.
Okay. Well, so we understood what is square number. They are square numbers because they can be represented as a rectangle with same length and breadth, or we can say they can be represented as a square. Let us write examples here. 1, 4, 9, 16, 25, 36, 49, 64, and so on. Now you might be thinking how to find these square numbers readily available without thinking too much. It's very easy. 1 is nothing but 1 square. 4 is nothing but 2 square. 9 is 3 square, then 4 square, then 5 square, then 6 square, then 7 square, then 8 square, and then so on. It's very easy. You can find these square numbers so easily, ready to say, ready to use. Just consider those natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and square them. You will get the continuous square numbers. 1 square is 1, first square number. 2 square is 4, second square number. 3 square is 9, next. 4 square is 16, next. 5 square 25, next. 6 square 36. 7 square 49, 8 square 64, 9 square 81, 10 square 100, 11 square 121. This way it's very easy to find out those square numbers. Okay, now there are some more patterns we have to look at. We have to see the properties of square numbers. Before that, let us collect square numbers at till first 25 or 30 square numbers. Let us write first 30 square numbers. First 30 square numbers. Ready?
Yes.
1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square. Am I writing correctly?
Yes, sir.
8 square, 9 square, 10 square, 11 square, 12 square, 13 square, 14 square, 15 square, 16 square. You have to just multiply 16 with 16. You will do 16 with 16 and you will get 16 square. 16 square means 16 into 16. Just multiply and you get that square number. 17 square, 18 square. Can anyone tell me what is 19 square?
No.
19 square. That's wrong. How can it be lesser than that? How can it be lesser than 18 square, David? 19 square must be greater than 18 square. 19 is greater than 18. So 19 square should also be greater than 18 square. You are telling lesser than that. 18 square is 324. This is 361. At least, maybe you don't remember that number, but at least you should know that 19 square cannot be smaller than 18 square. At least use this common sense. 20 square, 21 square, 22 square, 23 square, 24 square, 23 square is 529, I guess. I'll cross check because I don't remember it perfectly. I'll cross check. 3 3s are 9, 3 2s are 6 2s are 12, 3 2s are 4. Yes, that's correct. Now 24 square, 25 square, 26 square, 27 square, 27 square, I don't remember. What is that? See, I am doing that short calculation. 7 7 ja 49, 7 2 ja 14, 2 ja 28, 2 2 ja 4 plus 2. 4 plus, wait, it was 7 7 ja 49. Yeah, that carry on, forgot. 7 7 ja 49, 4 carries. 7 2 ja 14, 14 2 ja 28 plus 4, 28 plus 4, 32. And 3 carries, 2 to the 4 plus 3, 729. 28 square, I guess 784, isn't it? 784, 8 8 is 64, 6 carried, 8 to the 16 to the 32 plus 6, 38, 3 carried, yes, 784. And 29 square, 841, 30 square, 900. So these are our first 30 square numbers. I'll teach you how to do this short calculation to find 27 square, 28 square. If you forget, you can quickly do it. I'll teach you all these tricks.
Okay.
Well, but I want you to remember at least 30, first 30 square numbers. Will you do?
Yes.
Can I cross check it in the next class?
Yes.
Anurag, what do you say? Don't say anything. Where are you? Four square, 5 square, 6 square, 7 square, 8 square, 9 square, 10 square, 11 square, 12 square, 13 square, 14 square, 15 square, 16 square, 17 square, 18 square, 19 square, 20 square, 21 square, 22 square, 23 square, 24 square, 25 square, 26 square, 27 square, 28 square, 29 square, and lastly 30 square. We can go ahead of that as well, but presently not. Presently we want to cover only first 30 square numbers. Okay? So in the next class, I hope you will tell me, if I ask you what is 27 square, you will quickly tell me 729. If I ask you what is 29 square, you will say 841. Will you be able to do that?
Okay.
Where are you, Anurag? You are not there.
This video is also sir.
Maybe he is away.
Okay, sir.
Give me a moment.
Okay, sir.
Now look at these square numbers, first 30 square numbers. Let us find out some important things about them. Some important things about them. Check out all these numbers and tell me, do you see 2 at the ones place of any of them? Ones place of any of them?
In 12 squares and 22 squares, sir.
So in the 12 square you see 2 at the ones place. Oh, I am then not looking it correctly. I see it's 4, but you see it's 2. Maybe you are right, maybe I am wrong.
I thought that was 12 squares.
Oh my god, I am talking about square numbers. You forgot what is a square number? So quickly you got confused. You can't retain the concepts even for 5 to 10 minutes. Even for 5 to 10 minutes. Why so confused? Why so confused? I am talking about the square numbers. I wrote it first. You are not attentive in the class. I say something, you understand something else. You are not attentive. Anurag, these are our first 30 square numbers. Do you see 2 at the ones place of any of them? Ones place 2 in any of them?
No, sir.
Do you see 7 at ones place of any of them?
No, sir.
Check it properly. 7 at ones place, any of them?
So there is no 7 at 1 space.
Do you see 8 at ones place of any of them? 8 at ones place in any of them?
No, sir.
Do you see 3 in any one at the ones place of any of them?
No, sir. No, sir.
Do you see 0 at ones place somewhere?
Yes, sir.
Do you see 1 at ones place?
Yes.
Do you see 4 at ones place? Anyone in anyone?
Yes, sir.
5,
Yes, sir.
6,
Yes, sir.
9.
Yes, sir. Yes, sir.
Notice there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of which these 4 numbers, these 4 digits, I mean 2, 3, 7, 8 never comes at one's place. Oh, that's a great observation. Very interesting fact. You make the numbers a square and you never see 2, 3, 7, 8 at one's place. Oh my god, that's a amazing fact. So you square any number. You square any number. Maybe it is a small or big. Maybe it is 2-digit number, 3-digit number, 4-digit number, 5-digit number, any number. You square any number. You will never see ones place with 2, 3, 7 or 8. Only 0, 1, 4, 5, 6, 9. Only these 5 letters will, these 6 digits will come at one's place, not these 4. Isn't it very amazing fact? Oh my god, I got that very amazing fact. Do you think it's amazing?
I think that's a no.
Yes, sir, I also.
So let's note it down. If we noticed something very important, we should remember 2, 3, 7 and 8 never comes at one's place, or you can say units place of the square of any number, square of any natural number. Any natural number, you square it, these digits will never come. So how this is helpful? This is helpful. Suppose someone randomly tells us 1578, tell me it is square number or not. You will say no, one's place is 8. It's not possible. This is not a square number. Without checking much things, you can quickly say this is not a square number. Isn't it?
Yes, sir.
If someone tells you, someone asks you, if 1578 is a square number, you will say quickly, no, it's not possible, because 2, 3, 7 and 8 never comes at one's place of the square of any natural number.
Okay.
So this is the square of none. There is no number squaring which we can get this. There is no such number. Got it?
Yes.
Number 2, the square of any natural number only contains 0, 1, 4, 5, 6, 9 at one's place. Is that clear?
Yes, sir.
Yes, sir.
So now if someone asks you 1576 is a perfect square, I mean a square number or not, what you will say, yes or no? Quickly.
Yes, sir. That's a perfect
No.
number.
Yes, sir.
No, wait. If you say quickly yes or if you say quickly no, you may go wrong, dear. You said quickly yes, you went wrong. you may go wrong. Notice 2, 3, 7, 8 never comes. That is guaranteed. But it is telling 0, 1, 4, 5, 6, 9 comes at the units place, ones place of a square of any number. So it's not guaranteed. You have to check. Okay.
Okay, sir.
If square of any number contains 0, 1, 4, 5, 6 or 9 at one's place, if the square of any number, any natural number actually, natural number contains 0, 1, 4, 5, 6 or 9 at one's place, it may or may not be a square number. If 2, 3, 7, 8 comes at one's place, then it is guaranteed it is not a square number. But if 0, 1, 4, 6 or 9 comes, 0, 1, 4, 5, 6 or 9 comes, then you have to check if it is square number or not. It may be or it may not be. Okay? So, don't just say yes or no without checking. Am I clear or not?
Clear. Clear, sir. Sir, how do we check?
I will tell you later. So, say yes or no. Say yes or no if following numbers are are square numbers. Ready? First, you have to be quick while saying yes or no. Okay?
Okay, sir. Okay, sir.
5,368. Yes or no? Quick, quick, quick.
No, sir. No, sir. No.
No, sir.
Okay, very good. It's no. Because of one's place being 8, right?
Yes, sir.
Yes, sir.
Second, 6,872. Yes or no? Quick.
No, sir.
No, sir.
Wow. Intelligent. Third one. 7,261. Say yes or no?
yes,
Quick,
Yes,
quick.
yes.
How did you say yes, sir? Is this a guarantee? One's place is 1, so it will be one's place, square number.
That's not a guarantee.
I taught this here. If 2, 3, 7, 8 comes at one's place, that is a square number. That is not a square number. But if 0, 1, 4, 5, 6 or 9 comes, then it is not guaranteed. It may be or it may not be. Both chances are there. Both chances are there.
What should I say?
So you have to check. Have to check. Have to check. We cannot say yes or no. Have to check. How to check? I'll tell you later. But at least be right at your end. Don't be wrong. Correct?
Yes, sir.
Yes, sir.
those who are watching it on social media are also responding. Okay, so be careful while answering such questions. Next, 2986. Quick, quick,
Have
It
to
may be
check.
or may not be.
have to check. May or may not be also good. If you say may or may not be, that is also good. It's possible, but we have to check, right?
Yes, sir.
Yes, sir.
Okay. But how to check, I will teach you later. How to check will be taught later. Or let's do it now, not later. Let's do it now. How to check if a number is a perfect square, I mean a square number. How to check if a number, a given number is a square number. Okay.
Okay, sir.
Okay, sir.
See, the answer is prime factorization. What's the answer?
Prime factorization, sir.
Prime
Prime
factorization.
factorization.
By doing prime factorization, we can do it. We can do it. If every factor is paired, if every factor has a square over it, then it's square number. If every factor has square like this over it, then the number is a square number. Is that okay?
Yes, sir.
Let us check with some examples. Check by prime factorization. If $512 is a square number. This is our question. Check by prime factorization if 512 is a square number. Let us do prime factorization. I hope you understand prime factorization. Do you understand it?
Yes.
You might have studied it in previous classes, 6th or 7th.
Yes, sir.
So if you have 512, you have to divide it by any prime number. Only prime number. You can't divide it by 4. You can't divide it by 6 because 4, 6, these are not prime numbers. You have to divide by only prime numbers. What are prime numbers? 2, 3, 5, 7, 11. Numbers which have only 2 different factors. Only 2 different factors are prime numbers. So you have to divide it by prime numbers. First, let us divide by 2. By 2 in how many times? 256, right? Again by 2 only. 128, again by 2, 64, again by 2, 32, again by 2, 16, again by 2, 8, again by 2, 4, by 2 again, 2 2s are 4, and at last by 2 again in one time, 2 1s are 2. So you stop when 1 comes in the bottom. 1 comes in the bottom, you stop. Now notice how many times, how many factors you got. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 2. 2 times 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 2. 9. So 512 is equal to 2 raised to the power 9. Which, wait, just let us finish it. 2 square times 2 square times 2 square times 2 square times 2. See, there are total 9. 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 1, 9. Total 9 factors, right? Do you think all the factors have a square over them? Do you think every factor has a square over them?
No, sir.
No. This one is not having a square. So 512 is not a perfect square number, not a square number. Since 2 has no square, since a factor has no square, so 512 is not a square number. Not a square number. Done. This is how we can check if a given number. But there is another method also, right? If I don't use prime factorization, do I have another method? Do I have another method to answer it? Yes, I have. Its ones place is 2. So it can never be a square number. So easy answer. I taught this already. Ones place is 2. It can never be a square number. But the question was telling to do it with prime factorization. That's why I showed it with prime factorization. So there are two methods to check. Ones place is 2. So never a square number. Using prime factorization also we got the same answer, not a square number. Well, now class ends here. Bye bye for now. We'll do the science class later. in the next class.
Bye, sir.
Bye bye.